Okay, you're welcome to Biomathematics, and we are starting a new series today. It's a long topic that I would like you go through it with you. So the first one here is coordinate geometry 1. We'll be taking straight line, which is loci, and then the first thing, introduction to this particular topic, is distance between 2 points. Distance between 2 points, and we'll be using a Cartesian plane. This is a Cartesian plane which you call xy plane. So this usually denoted as y, and this is denoted as x. So want to have the formula for calculation of distance between 2 points. So let's assume that we have a point here, and then we have another point here on this Cartesian plane. You know, on a Cartesian plane, whenever you have a point here, for every value of x, there's a corresponding value of y. So let's assume that we have this 2 point point AB, and this is point A, this is point B. So you see here, we can decide to a kind of, let's say, draw this down, so that let me have a straight line or broken line, whichever one. Then we'll have also another broken line or thick line, whichever one. So you see, from here to here, we can tag this as from here to here 2, from here to here, this is x1, to here, this is x2, and then you have this one also like this is y1. Then the same thing when you have this also, this is y2. So by implication, you see that this made a right angle triangle here. So we can draw something from here to here is x2 minus x1. The same thing from this to this is y2 minus y1. That's the height. That's the height. So since that is so, we have what we call coordinate. The coordinate here will be, for coordinate for every x1 here, there is also y1. The same thing here, this will be x2 comma y2. Please follow me on this one, because we'll be making use of all of this. Now we want to know the distance AB. The distance AB. So let's tag this place here C. Let's let this point here be C. And you remember there's a relationship in elementary trigonometry by the great mathematician Pythagoras, that stated that the square of the hypotenuse, that is A and B, is equals to the square of x2 minus x1 whole square, then plus the square of y2 minus y1 whole square. That is, the square of the hypotenuse is directly proportional to the sum of the square of the two other sides. That's Pythagoras theorem. So having gotten by Pythagoras theorem, then it means that this will be AB. We take this square to the other side, which will give us the same thing as the square root of open bracket x2 minus x1 whole square plus open bracket y2 minus y1 close bracket square, close bracket square. So this formula. I will tag this formula equation 1. Permit me, I will tag this equation 1. So this equation 1 is what we call the formula for calculating distance between 2 points on a Cartesian plane. We'll take example from this so that we can be able to see how we apply this one here. Okay, we have an example here, and in this example we are to find the distance between -2. The first coordinate is -2, 3, and the second coordinate is 5, -4. So let's solve this together. Solution. solution. So this itself, we will have this to be, let's say our A is minus 2 comma 3 and our B is 5 comma minus 4. So now what is happening here is that this one here is x1, this is y1, this is x2, and this is y2. So recall the formula. This is the formula that we've used. We've already derived this formula from this plane. So we'll apply this formula directly. So it will be AB is equals to the square root of, remember, this is our x2, so that will be 5. So this is 5 minus our x1 is minus 2 all square plus another bracket, our y2 is minus 4, and then 3 we have minus 3 close bracket all square. So this is the same thing as we have the square root of this. Minus minus is plus, so this one will give us 7. This plus this is 7, and the square of 7 is 49. So plus minus this minus 7. When you square minus 7, it will be plus 49. So this will give us 49. So we can sum this one together so that we'll have this to be the same thing as the square root of 98. So now here, since it is 98, we can be able to solve this one by using the knowledge of sort. So we can express this one to be the same thing as the square root of 49 times 2. 49 times 2 is 98. This 49 is a perfect square, so that we'll have AB to be equals to square root of 49 is 7, and then we cannot find the square root of 2, so we leave it like this. If you want to leave your answer in decimals, it is still applicable. You can find the square root of 2. The square root of 2 is 1.412 thereabout. So we can just continue here and say this is same thing as 7 times 1.412. So we can approximately 7 times this one will give us 14, carry 1. Then this times 7 is 7 plus 1, that will be 8. And then 4 times this is 20. 4 times 7, that will give us 48. So it means by implication that will give us this. That we will write as 8 again, 0.8 again. 7 times 1 will give us 7 plus 2. Then we have this to be 9.882. You must not leave it this way. It is not. Your final answer should be this one. So this is how we solve problems on how to calculate distance of between 2 points on a Cartesian. Okay, here it's for midpoint.